Swayam Prabha. Digital India. Educated India.
Okay. So, now we have last class we have derived that R and I expression, TI expression, transmit intensity coefficient for the sound transmission. Because what I want, we want that suppose I play a box in this room and there is a wall of thickness L, then I want how much energy, acoustic energy from this room will be transmitted in the corridor. Okay. There is a corridor after the wall. Okay. That is why similarly, I can say if there is some sound in the corridor of intensity I, how much intensity of that sound will be transmitted inside the studio if I know the thickness of the wall and characteristic impedance of the wall. Okay. So, in case of these things, if the thickness of the wall is L, then TI transmission coefficient is nothing but a 4 by 2 plus R3 by R1 plus R1 by R3 into cos square K2L plus R2 by R1 R3, R2 square by R1 R3 plus R1 R3 by R2 square into sin square K2L. That is the transmission coefficient. Now, if I consider that R1 and R3 is equal, what is the meaning? That means sound is transmitted from air medium of inside this room to the wall, and after the wall there is another air medium. Let the two air medium is same, that means R1 is equal to R3. Then TI will be, what will be TI? I place R1 is equal to R3, then TI will be 1 by 1 plus 1 by 4 R2 by R1 minus R1 by R2 whole square sin square K2L. Sin square K2L. I put R1 is equal to R3 in this equation. So, R1 is equal to R3, this is 1, this is again 1, 1 plus 1 again 2, 2 cos square K2L, okay, plus R2, R1 R3 is same. So, this is R1 square, this is R1 square, R2 by R1, R2 by R1, so R2 by R1 plus R2 by R1, so 2 R2 R1 square. So, in that case if I simplify that things, if R1 is equal to R3, I get 1 by 1 plus 1 by 4 R2 by R1 minus R1 by R2 whole square into sin square K2L. Okay. Now, in this equation, if I say that R2 is much greater than R1, what I said, R2 is much greater than R1. What is the meaning? Physical meaning? That this is the air, impedance of the acoustic impedance of the air compared to the solid wall. The solid wall is R2. So, solid wall is much higher than the acoustic impedance of the air. So, if in that case R2 is much greater than R1, then again it will be simplified to what? Again TI will be simplified to, TI will be equal to 1 by 1 plus 1 by 4 R2 by R1 whole square sin square K2L, sin square K2L. R1 is much less than R2. Okay. This implied to the transmission of the sound from air in one room through the solid wall into the adjacent room. Okay. So, this is the transmitted coefficient. TI is 1 plus 1 by 4 R2 by R1 whole square sin square K2L. Okay. Sin square K2L. Now, if I consider that R2 by R1 sin K2L is much greater than 2, greater than 2, then Ti will be 1 by 2 R1 divided by R2 into sin square K2L whole square. I consider that R2 by R1 sin K2L is much greater than 2. In that case, that this equation will be simplified to 2 R1 by R2 into sin square K2L whole square. Okay. This 1 will be ignored and 4 will be, okay. You understand? So, now 2 R1 means 4 R1 square divided by R2 sin square K2L. I can ignore this one. Okay. So, now if K2L, now another simplification. So, what I said that R2 by R1 sin K2L is much greater than 2. What is R2? R2 is the characteristic impedance of wall, R1 is characteristic impedance of the air into sin K2L, L is the thickness of the wall. Okay. Now, if sin K2L is less equal to K2L, sin theta is equal to theta, sin K2L is equal to K2L, sin theta is almost equal to theta, then I can say that Ti is nothing but a 2 R1 divided by R2 K2L whole square. Okay. So, transmitted pressure intensity is inversely proportional to the transmitted pressure intensity is varies with the L square. So, I can say the transmitted pressure is varies inversely proportional to the L thickness of the wall L. So, I can say P is pressure amplitude is inversely proportional to the thickness of the length of the thickness of the wall. Okay. So, if the thickness wall of the wall is increases, if the thickness of the wall is increases, then the pressure transmitted pressure amplitude will be decreases, and Ti is nothing but a proportional to 1 by L square. So, if thickness of the wall is larger, then there is a chance of less intensity of sound will pass through the wall in the next room. So, suppose I want to build a studio or auditorium. If I do not want that outside sound should not go inside that auditorium, the thickness of the wall of the auditorium must be larger. Okay. So, if the thickness is increases, the sound outside sound enter in the intensity of the outside sound which is entered in the auditorium will be less. Similarly, the sound which will be in the inside that auditorium will be going outside the auditorium will be very less. So, thickness of the wall is inversely proportional to the transmitted pressure amplitude. Okay. For thin plane or low frequency, if let that another condition, the condition is that if R1 R2 by R1 into sin K2L is less than 1, I said R2 by R1 and sin K2L is much less than 1, much less than 1, then Ti will be 1. Okay. Ti will be 1. If Ti is equal to 1, that means if L is very thin, L is very low such that R2 by R1 into sin K2L is less than much less than 1, then the partition, that second medium R2 does not affect the sound transmission. Okay. Does not affect the sound transmission. So, think about practically, there is a two fluid separated by a very thin membrane which L is so low that R2 by R1 sin K2L is much less than 1, then the sound produced in the one fluid will be completely transmitted to the next fluid. So, the separation does not affect the sound transmission. Okay. Separation does not affect the sound transmission. So, thin membrane I can separate the two fluid, but it does not affect the sound transmission. Okay. The intermediate fluid is larger catalytic impedance, either the fluid one but small, so it is okay. Now I go for the other condition. Let us K2L, this is the Ti expression, expression of Ti is this one, this is nothing but a Ti. Okay. Now put the condition number 3. What are the condition? I proved that thickness of the intensity pressure is inversely proportional to that things I proved. Now let us, this is the Ti. The condition is that K2L is nothing but a n pi. K2L is nothing but a cos square K2L. Cos square K2L is nothing but a n pi. So integer multiple of pi cos square K2L. So then Ti will be what? Ti will be 4 R3 by R1 divided by R3 plus R1 whole square. K2L is equal to n pi. I put the K2L in n pi, then in this equation, then I get that Ti is nothing but a 4 R3 into R1 divided by R3 plus R1, because this term will be 0. Okay. Now if it is, this is the condition, so what is the what do you mean by K2L is equal to n pi? K2L is equal to n pi, then what is the frequency f? F is nothing but a n C2 divided by 2L. What is C2? C2 is the velocity of the sound in the second medium, n is the integer number, and 2 into L is the length of the wall. So I can say L is nothing but a n lambda 2 divided by 2. So I can say if the thickness of the wall is the integer multiple of lambda 2 by 2, that means the wavelength is lambda 2 in those frequency whose wavelength by half wavelength is integer multiple of half of the wavelength is equal to the L. In case of those frequency, the Ti will be this one. Ti will be R3 4 into R3 plus R1, R3 into R1 divided by R3 plus R1 whole square. If R1 and R3 are equal, then it is nothing but a this 4 R1 square divided by R1 plus 2 R1. So it is 4 R1 square. It is nothing but a 1. So those frequency will be passed through the wall. If the length of the wall is the integer multiple of the half wavelength of the frequency, then those frequency will be pass of the wall. Similarly, if the K2L is equal to n minus half pi, or I can say the L is equal to 2n minus 1 into lambda 2 by 4, then also Ti will be 4 R1 R3 divided by R2 plus R1 R3 divided by R2 whole square. In that case, K2 is, if the K2L is equal to n minus pi half pi, integer multiple of n minus half pi, or L is equal to 2n minus 1 by lambda 2 by 4, then the Ti will be 4 R1 R3 divided by R2 plus R1 R3 divided by R2, or R2 is, if the R2 is equal to root over of R1 plus R1 into R3, then Ti will be 1. Ti will be 1. If so, if the characteristics impedance of the second medium or intermediate medium is a geometric mean of the separate two medium, then the transmission coefficient will be the 1. Okay. So if for those frequency which is for which the L is equal to, if the L is equal to 2n minus 1 divided by lambda by 4, lambda 2 by 4, okay, wavelength divided by 4, and the R1 and R2 is the geometric mean of R1 R3, then Ti will be 1. For those frequency also the transmission coefficient will be 1. So, when I design that length of the wall and for acoustic studio, I have to think about what is the operating frequency condition. For that frequency condition also, I have to think about the L. I should not make the L such that if you see that L is nothing, if the L is an integer multiple of L is equal to the integer multiple of lambda by 2, integer multiple of lambda by 2. For those frequency for which the L is integer multiple of lambda by 2, the Ti will be 1. So, transmitted coefficient will be that the transmitted wave will be passed through the wall. Okay. So, this is the things we will use when we design that acoustic studio. Basically, thumb rule is that when you design a studio, the length of the wall or thickness of the wall must be such that pressure wave, you know that transmitted pressure wave amplitude will be inversely proportional to the length of the wall. So, if a thick wall, it will reduce the sound transmission from one room to another room, or I can increase the R2. So, now we have so far we have discussed about that plane wave propagation and spherical wave propagation. Okay. Now, how that wave is transmitted means that when that acoustic wave is generated and passes through the medium, and if say that that wave is fall into the one surface of the another medium, that the wave is transmitted in the air medium, then it fall on the wall, that will be a solid medium. So, how that sound will be transmitted? That means some portion of the sound will be reflected, some portion of the sound will be transmitted, and there will be other phenomena like that sound diffraction and then interference. So, those phenomena we will discuss in this class. Okay. So, that any sound or you can say acoustic wave has a wave front. What is wave front? 2 or 3 dimensional wave can be represented by a wave fronts which are curve of surface where all the waves have the same phase. If you see the blue line, all are the wave fronts. So, within the line the wave have the same phase, within the line wave has the same phase, and line perpendicular to the wave front is called ray. As per the figure, if you see that this magenta color line perpendicular to the wave is called ray. The ray direction is the direction of the propagation of the wave. So, if you throw a stone on a pond, you see that a wave is generated. Okay. So, that wave is propagated towards the bank of the river or bank of the pond. So, that the propagation direction of the propagation is the pointed by the ray. Okay. Now, if this way wave is propagated, then there will be interference. Suppose I have an wave like this and another wave is approaching like this. Okay. So, when the two waves are passes in the same point, there will be interference will be happen in the same point. Suppose this point, then there will be interference will be happen between the two waves. Okay. So, now this interference support the superposition principle, means at the point of interference the particle displacement due to the both wave is the arithmetic sum of the displacement of the first wave and the displacement of the second wave. So, you understand. So, that means at point of interaction it support the superposition principle. That means the displacement of the particle due to the first wave plus displacement of the particle due to the second wave, the arithmetic sum of those two displacement is the resultant displacement at the point of interaction. So, if you see the figure in here, let us one wave is going this direction and another wave is negative phase going in reverse directions. So, if they meet at certain point, when they interact at a certain point, then there will be a destructive interference, because this amplitude and this amplitude is negative and this amplitude is positive. So, negative. So, let this A, this is minus A plus minus A is equal to 0. So, destructive interference will be happen. Similarly, if both waves are in the same phase at the point of interaction, then their arithmetic sum will be double the first individual wave. Okay. Similarly, when the two waves are interference with a slight bit of phase change, then different kind of amplitude will be happen. Let us see the figure like this way. See that two waves, let us sinusoidal waves, are, if they are same phase and interference in one point, then the amplitude will be added up. Okay. If the two waves are in opposite phase interference, then the amplitude will be destructive. Okay. So, 0. If there is a slight change of phase, then there will be a resultant wave will be generated based on the arithmetic sum of the two points. So, this is called wave interference. You know that if the sine wave is passes another sine wave, if you add together, if they are same phase, the amplitude will be double. If they are opposite phase, amplitude will be 0. If there are slight phase difference, then at any point this will be the arithmetic sum of the of the two waves. Okay. Similarly, there will be diffraction. When wave encounter an obstacle, if you see in the pond there is a wave. If you put a log, wooden log there, you see there is some portion behind the log, there will be no interference. Okay, there is no wave. So, this is called diffraction. The wave is diffracted by the log. So, when a wave encounter an obstacle, the bend around the obstacle and create a shadow region. This region is called, this phenomena is called diffraction. So, how diffraction depend? Diffraction depend on the size of the obstacle. If the size of the obstacle compared to wavelength is very less or negligible, then you see there is no diffraction. If you see the picture A, there is no diffraction, not at all a diffraction, because the wavelength of the wave and the length of the obstacle is very less. Length of the obstacle is very less compared to the wavelength. So, that is why the diffraction is not happened. Now, if the length of the obstacle is larger, then the diffraction will be larger. So, that is called the sound diffraction. Okay. Then there will be a reflection phenomena. Suppose an acoustic wave propagated in this room and just incided on the wall. So, what will happen? Some portion of the acoustic wave reflected back from the wall. Okay. So, that is called the wave reflection, and reflection is also follow the same principle as the light. That means, the incident angle is equal to the reflected angle. So, angle of incident will be same as the angle of reflection. Okay. So, that is the same as the light wave. Similarly, there will be a refraction also. Some portion of the acoustic wave transmitted inside the wall. Okay. So, that is called refraction. So, these two phenomena will details analyze in this lecture. With details we can say the detail we discuss the mathematics of that transmission and reflection, so that we can calculate the intensity. Suppose I play in practical example. Suppose I want to produce a sound of 60 dB in this room, and I do not want to that sound should be go in outside the room. So, what should the wall thickness? That we have to decide. How should I treat the wall so that the sound produced inside the room does not pass the next room. So, those kind of phenomena, that is sound transmission. So, that sound transmission will be discussed in this class. Okay. Details of that sound transmission. So, let us forget about that things. Let us think that all that theory which will discuss here, all are derived based on the fluids, but same phenomena will exist for solid and air also. So, there is a two fluids. This is the fluid number 1 and this is the fluid number 2, or you can say this is a medium 1 and this is the medium 1. So, one wave, let us acoustic wave, normally incident in the boundary of the two medium. So, that is called incident wave. So, this is pressure is Pi, and the same if it is normally incident, the reflection also will be the normally. So, it is PR is the reflected wave, and some portion wave will be transmitted in the second medium, that is PT. Okay. So, that is called transmitted wave, transmitted pressure wave. So, this is a pressure wave Pi. So, what is the expression of Pi? Pi is nothing but a, let us amplitude of the Pi is e to the power j omega t minus k1 x. Okay. So, let us this medium is acoustic impedance is R1 and this medium has R2. What is R1? R1 is nothing but a rho 1 and C1, and R2 is nothing but a rho 2 C2. So, since the velocity of the sound in the two medium are different, the wave number, although the frequency of the incident wave, pressure wave, and frequency of the transmitted pressure will be same, but since the k is nothing but a omega by c, this is called wave number, k is nothing but a omega by c. So since omega c is difference, the wave number will be difference. So that's why if I say that wave number of this medium is k1 and wave number of this medium is k2, then I can say pi is nothing but a pi e to the power j omega t minus kx. Similarly, what is pr? Pr is pr amplitude e to the power j omega t plus k1x. Why it is plus k1x? Because the direction of the propagation of the reflected wave is reversed from the incident wave. That's why it is plus k1x. Similarly, what is ptx? Pt is nothing but a pt amplitude e to the power j omega t minus k2x, because medium is different, that's why wave number is different. Okay. Now, if I want to know what is the reflection coefficient? Reflection coefficient of this incident. So, reflection coefficient R is nothing but a reflected pressure wave divided by incident pressure wave. Reflected pressure wave amplitude divided by incident pressure wave amplitude. So, what is the transmission coefficient? T is nothing but a Pt by Pi, transmitted pressure wave divided by incident pressure wave, transmission coefficient. Okay. Now, reflection coefficient, transmitted coefficient for the pressure. Now, if I say what amount of intensity will be transmitted and amount of intensity will be reflected. So, I want to find out the intensity coefficient of that incident wave. So, if I say Ti is the transmitted intensity coefficient, it is nothing but a IT, transmitted intensity divided by incident intensity, divided by incident intensity. What is transmitted intensity? You know, the intensity I is nothing but a p square by 2 rho c, 2r, p square by 2r. So, I can say IT is nothing but a pt square divided by 2r2 divided by pi square divided by 2r1. Okay. So, this is nothing but a r1 by r2 into pt square divided by pi square. Okay. So, it is nothing but a r1 by r2 into t square. T is the pressure coefficient, r1 by r2 into t square. Similarly, what is reflection intensity coefficient, the reflected intensity coefficient? So, Ri is nothing but a IR divided by II, IR divided by IR. So, what is IR? IR is nothing but a PR square divided by 2R1. Similarly, what is II? It is nothing but a PI square divided by 2R1. So, it is nothing but a PR square divided by PI square, which is nothing but a R square. Okay. So, Ri is nothing but a R square and Ti is nothing but a R1 by R2 into T square, where T is the pressure coefficient, R is the pressure coefficient for reflected coefficient. So, T is the transmitted coefficient of the pressure, R is the reflected coefficient of the pressure. Okay. Similarly, if I want to find out what is the power coefficient, transmitted power coefficient and reflected power coefficient. What is transmitted power coefficient? T pi, nothing but a power is nothing but a intensity multiplied by area, cross sectional area. Let us think about incident ray has an area like this kind of beam channel is incident on the surface. So, incident ray area is AI. Same area will be reflected. So, this area of the reflected coefficient will be also AI, but transmitted coefficient, transmitted pressure area may be different. Let us it is 80. Okay. So, it is 80. So, I can say what is Ti? Transmitted power divided by the incident power. What is transmitted power? It is nothing but a IT into AT divided by II into AI. So it is nothing but a AT by AI into IT by II. IT by II means nothing but a TI. So it is nothing but a into TI. Okay. Similarly, what is R pi? R pi is nothing but a IR into AI divided by reflected power divided by the incident pressure, II into AI. So AI cancel, it is nothing but a IR by II, which is nothing but a R square, So, but if you see the T pi plus R pi, total incident power is nothing but a reflected power plus transmitted power. So, T pi plus R pi coefficient must be equal to 1. So, total power is equal. So, this power is nothing but this power plus this power. So, power coefficient for reflected coefficient and transmission coefficient sum must be equal to 1. Okay. So, you understand this thing. Now consider what will happen in case of PR. Now, I want to find out how much intensity of the value of that all coefficient, transmitted coefficient and reflected coefficient. How do I find out the value? I say that a ray of Pi, pressure wave is Pi, is incident normally on the boundary. So, there will be a reflected wave which is also PR, is normal to the boundary, and there will be a transmitted ray PT. So, I know Pi, PR and PT. Okay. Now, what are the boundary condition? At the boundary, the pressure on this side of the boundary must be equal to the pressure on this side of the boundary. Have you understand or not? Pressure on this side will be equal to the pressure on this side. So, both side will be pressure will be equal. When the both side pressure will be equal, so if I write the expression, if the pressure is equal, this is a condition number 1, boundary condition 1, pressure on both side will be equal. The acoustic pressure on both side of the boundary must be equal. So, acoustic pressure on this side is nothing but a Pi plus PR, okay, is equal to must be PT. This is the condition number 1, and the condition number 2 is the normal component. If you see, the normal component of the particle velocity on both sides of the boundary must be equal. So, normal component of the particle velocity on both sides of the boundary must be equal. So, I can write Ui plus Ur should be equal to Ut. So, this is the equation number 1 and this is equation number 2, where when the boundary is here, that is x equal to, boundary is at x equal to 0. Okay. So, at x equal to 0, Pi plus PR is equal to PT and Ui plus Ur is equal to Ut, both the equation. So, now I divided equation number 1 by equation number 2. So, I can write Pi plus PT divided by Ui plus Ut, Pi plus PR divided by Ui by Ur is nothing but a PT by Ut. Equation number 1 divided by equation number 2. Now, what is the relation between the P and U? P is nothing but a plus minus Ru. R is the acoustic impedance. P is nothing but a plus minus Ru. So, Pi plus PR divided by what is Ui? Ui is nothing but a Pi divided by R1. Same medium, this is the R1 and this is R2. Reflected wave, direction of the propagation is different. So, 180 degree phase shift. So, minus PR by R1 is equal to P2 by PT by R2. Okay. So, I can write from there that Pi minus PR divided by Pi plus PR, Pi minus PR is equal to PT by, so it is nothing but a, so R1 will be here and it is nothing but a R2. Okay. So, at x equal to 0, Pi is nothing but only amplitude at x equal to 0. So, Pi is nothing but at x equal to 0, at x equal to 0, at x equal to 0. So, Pi is R1 into Pi into e to the power j omega t, okay, plus Pr into e to the power j omega t divided by Pi into e to the power j omega t minus Pr into e to the power j omega t is equal to R2. Okay. So, j omega t will be cancelled. Okay. So, I can say the R1 Pi minus Pi plus Pr divided by Pi minus Pr is nothing but a R2 by R1. Okay. So, if I divided by Pi, so 1 plus R, Pi Pr by Pi, 1 plus R is nothing but a 1 minus R is equal to R2 by R1. Okay. So, I can find out from here R is nothing but a R2 minus R1 divided by R2 plus R1. Okay or not? From here I can find out R is nothing but a R2 minus R1 divided by R2 plus R1. So, reflected coefficient R for this normal incident is nothing but a R2 minus R1 divided by R2 plus R1. What is transmitted coefficient? What is equation number 1? Pi plus Pr is equal to Pt. Okay. So, if I divided by Pi, so it is nothing but a 1 plus R is equal to T. So, if I do that, then T is equal to 1 plus R2 minus R1 divided by R2 plus R1. So, it is nothing but a 2 R2 divided by R2 plus R1. So, transmitted coefficient T is nothing but a 2 R2 divided by R2 plus R1. Okay. Now, what is Ri? What is Ri? Ri is nothing but a R square. What is Ri? Ri, intensity coefficient, is nothing but a R square. What is Ti? Is nothing but a R2 by R1 into T square. So, I know the T value, I know the R value, I can find out the Ri, intensity coefficient. Okay. Now, if I put the condition, then let us see what are the condition is available. The first condition is that if R1 is less than R2. What do you mean by R1 is less than? Characteristics impedance of the first media is less than the characteristics impedance of the second medium. So, example is that like a wave is transmitted from air to a concrete wall. So, air characteristic impedance ρ1 C1 is less than the characteristic impedance of the concrete wall. So, a wave is transmitted from air to solid wall. In that case, that R is always positive, R will be always positive and T will be always positive. R will be positive and T will be positive. So, I can get the value of R and T if I know the R1 and R2 value. Okay. But if you consider when R2 is less than R1 or R1 is greater than R2, that means a wave is transmitted from the solid wall to air. Wave is transmitted from solid wall to air. Okay. In that case, R will be, reflection coefficient will be negative. R1 is greater than, so R will be negative. Okay. Similarly, if R2 is equal to R1, means two media characteristic impedance is same, then reflected coefficient R is equal to 0, R2 is equal to R1. So, R1 minus R2 is equal to 0 and transmitted coefficient T is equal to 1. So, that means if the two medium is same, then the total transmission will be happen, there will be no reflection. Okay. So, this is the three condition. So, if a wave is passing only within the air, so there will be total transmission in the wave, there is no reflection by the air. Okay, if the characteristic impedance of the whole medium is same. Okay. Now, what are the implications of this phenomena? Now, if I consider mathematically that R1 by R2 is tends to 0, what will happen? If R1 by R2, I can write down this thing is nothing but a R2 by R1 minus 1 divided by R2 by R1 plus 1. Okay. R1 by R2 tends to 0. Okay. So, the wave is reflected with no reduction in amplitude, no, then R will be 1, R will be 1 and T will be 2. Okay. So, what is the meaning? Meaning is that the wave is reflected with no reduction in amplitude, R is 1 and no change in phase. So, pressure coefficient R1 means the reflected pressure wave and incident pressure wave will be the same amplitude and no phase change, because all R is 1 plus 1, that means there is no phase change is happened. Now, if R1 by R2 it tends to infinity, then what will happen? Then again R will be minus 1, R will be minus 1. So, what is the meaning of the minus 1? So, in meaning of the minus 1 is that the amplitude is same, but phase is 180 degree shifted, 180 degree phase shift is happened. So, in that case that pressure wave amplitude is same, but the compared to incident wave, their pressure wave has a 180 degree phase shift. And what is T? In case of that, T is equal to 0. What is the meaning T equal to 0? The transmitted wave has a pressure amplitude which is equal to 0. Transmitted wave has a pressure amplitude Pt is equal to 0. So, that is why this condition is called pressure release condition, pressure release condition, pressure release boundary, and first condition is called rigid boundary. First condition is called rigid boundary and second condition is called pressure release boundary. Okay. Okay. So, you understand. So, that means if a wave is transmitted from one medium to another medium, if R1 by R2 is tends to infinity, that means that R2 is very small compared to R1, R1 is very high, that means R1 is very high means a wave is transmitted from a dense medium to lighter medium. In that case, if R1 by R2 is equal to infinity, in that case the boundary is called pressure release boundary. If R1 by R2 is equal to 0, the boundary is called rigid boundary. Okay. Boundary is called rigid boundary. Now, think about, let's I have another problem. The problem is that suppose a acoustics wave is generated in this room and acoustics wave is generated in this room in the air, and that wave is incident on the wall. Now, wall has a thickness. So, I said that I have a boundary, this is the room number 1. So, medium R1, room number air, acoustic wave generated in the room in air. So, that will fall on the boundary of the wall. This is the wall starting boundary. So, at x equal to 0. Now, I have a wall of thickness L. So, it is at x equal to L. So, thickness of the wall is L. Okay. Then, some portion of the incident, this is Pi, some portion of the incident wave will be transmitted in the second boundary inside the wall, that also incident in the, so this is R2. Let us, after the wall there is another boundary. So, let us, this is the room, acoustic wave generated in this room fall into the wall, and there is a corridor also, there is a air. So, after the wall there is a corridor air, so that wave will be transmitted in the corridor air. Okay. Let us, the corridor air is R3. Okay. So, if Pi is incident here, so there will be some transmitted wave which is Pa, let us say it is Pa, transmitted wave, and then that will fall on this wall, Pa will fall on this one and will be created a reflected wave which is Pb, okay, and some portion will be transmitted that side, which is Pt. Now find out the reflection coefficient of the pressure wave and transmission coefficient of the pressure, and some portion of here will be reflected, which is Pr. Okay. Now find out the R and T for this condition. That means I want to find out in practical cases that if the thickness of the wall is defined, then if I say that in this room I produce a 60 dB intensity sound, how much intensity of the sound will be released in the next room or next corridor, that I want to find out. So, if I want to get the transmission coefficient, then I can easily find out how much energy will be transmitted in the next room or after the wall. Okay. So, I want to find out that things. So, I have to find out T and R. So, what is T? I have to find out T and R, then I have to find out transmitted intensity coefficient and reflected intensity coefficient, then I can find out transmitted power coefficient and reflected power coefficient. All these things I can find out, and I can find out what is the effect of the L. If L is increases, is the power is reduced, transmitted power will be reduced. If L is decreases, is the transmitted power will be increases. So, what kind of effect of this L has on the has on the sound transmission, that I want to find out. Okay. So, that is called the 3 boundary transmission. Okay. So, there is a 2 boundary in this room, air to solid boundary, then solid to air boundary. Okay. So, there is a next boundary, air to solid boundary. Okay. Now, find out the equation first. What are the equation? You know, what are those equations? Equations are Pi is nothing but a amplitude Pi e to the power j omega t minus, if this is k1, the wave number in this medium is k1, wave number this medium is k2, wave number is k3. So, it is nothing but a k1 x. What is Pr? Pr is nothing but a Pr e to the power j omega t minus k1 x plus k1 x, because it is in the reverse direction. Okay. That is why I say this is plus k1 x. Similarly, if I say what is Pa? Pa is nothing but a let us amplitude is a e to the power j omega t minus k2 x. Okay. What is Pb? Again it is a reverse direction. So, it is nothing but a b e to the power j omega t plus k2 x. Okay. Similarly, what is Pt? Pt is nothing but a amplitude Pt into e to the power j omega t minus k3x. Okay. Okay. So, those are the equation. Those are the equation for the Pi, Pr, Pa, Pb, Pt. Now put the boundary condition. What are the boundary condition? There is a 2 boundary condition. At x equal to 0, at x equal to 0, the pressure on this side, which is Pi plus Pr, is equal to pressure on that side, which is Pa plus Pb. At x equal to 0, pressure on this side is equal to pressure on this side, and particle velocity normal component of the particle velocity ui plus ur is equal to nothing but a ua plus ub. Okay or not? Okay. But at x equal to L, what is there? Pa, total pressure in this side, Pa plus Pb is equal to Pt, and Ua plus Ub is equal to Ut. This is the boundary condition. So, this is the equation number 1, 2, 3 and 4. Okay. Now, if I divided equation number 1 by 2, so I can get Pi plus Pr divided by Ui plus Ur is equal to Pa plus Pb divided by Ua plus Ub. Okay. So at x equal to 0, x equal to 0 means x equal to 0. What is pi? Pi is nothing but a pi e to the power j omega t. Pi e to the power j omega t plus Pr into e to the power j omega t divided by, what is ui? Ui is nothing but a pi by r1. So I can write pi e to the power j omega t divided by r1 minus Pr into e to the power j omega t divided by r1 is equal to, what is Pa? Pa is nothing but a, this one with x equal to 0 means this term will be 0. So it is nothing but a e to the power j omega t plus b pb b e to the power j omega t divided by ua plus ub. So it is nothing but a e to the power j omega t minus b e to the power j omega t. This is divided by r2. This is divided by r2. So p is equal to, u is equal to p by r. So from there I can get, what I get? I will just rub here. So what I will get from there, from this equation, what I will get? Pi plus Pr divided by e to the power j omega t, cancel for all those things, divided by Pi minus Pr into r1 is equal to r2 into a plus b divided by a minus b. A plus b into a minus b. Now if I say at x equal to L, what I will get? At x equal to L, I said that equation number 3 divided by 4. So I get Pa plus Pb divided by Ua plus Ub is equal to Pt by Ut. Okay. So it is nothing but a, Pa is nothing but a, what is Pa? Pa at x equal to L, Pa is nothing but a Pa into e to the power j omega t minus k2L. Okay, plus Pb, what is Pb? Pb into e to the power, or a, sorry, it is a, amplitude is a, amplitude is b. So b into e to the power j omega t plus k2L at x equal to L divided by, what is Ua? A e to the power j omega t minus k2L minus b e to the power j omega t minus k2L, sorry, plus k2L, and whole this is divided by r2 and this is divided by r2 is equal to nothing but a pt divided by pt by r3. Okay. So now from there I can get, from there what I will get? I will get that a e to the power j omega t will be cancelled, r3 into p is nothing but a amplitude will be cancelled, e to the power j omega t minus at x equal to L, what is pt? E to the power j omega t minus pt cancel. So it is nothing but a r3. Okay, it is r3. Now what I will get? I get a into e to the power minus j k1L plus b into e to the power plus j k, not k1, it is k2, k2L into k2L divided by a e to the power minus j k2L minus b e to the power j k2L is equal to r3 by r2, r3 by r2. So these two equations, if I evaluate, equation number 1 and equation number 2, if I evaluate a and b, what I will get? I will get the expression of r. The expression of r, r is nothing but a, if I evaluate this equation number 1 and this equation number 2, or a b I replace, I will get r, reflection coefficient r is equal to 1 minus R1 by R3 into cos K3 K2L cos K2L plus j into R2 by R3 minus R1 by R2 sin K2L divided by 1 plus R1 by R3 cos K2L plus j into R2 by R3 plus R1 by R2 sin K2L. That I will get. So, I will get this expression. If you see this, this I will get the R expression, and from R expression I can get the Ti expression, transmitted coefficient expression. Okay. So, what is T? T is nothing but a 1 plus R. So, I can get 1 plus R, I can get T, and what is Ti? Ti is nothing but a R3 by R2 into that I will get. I get the Ti. So, then I get the Ti expression on this. I get the Ti expression. Okay. So, once I get the Ti expression, then I can calculate, I can impose the restriction in the next class. Okay.